Welcome to Lab 3 for our Ag Policy class. This is our Friday class meeting of the 7th week, replacing our in-class session. We're going to look at markets, policies, and welfare measures. Our topic for the last 2 weeks, we've been working mostly algebraically, a little bit graphically, and now let's get into a spreadsheet so that we could do several quantitative analysis at once. We're going to build that spreadsheet though. That means we're going to put formulas in that represent all this algebra that we've been doing in class. And of course, once we put it in a spreadsheet, we'll just be able to change values and get new solutions over and over, which is really our goal here. The goal of this lab is to do some tests that confirm the importance of these two pieces right here, the slope of the supply curve B and the slope of the demand curve D. So we've talked about that. We've done all of this sort of derivation work in class to show that those are important, that those are key, that those drive the distribution or the sharing of benefits and costs between the supply side and the demand side of the market. And so we should be able to confirm that with our model here. This one's a little bit different, so there's a handout for this week that goes with the lab. You can read through it and get the full explanation of what we're doing here, but the main difference is we're going to use a three-price model. And so in all of our welfare drawings on the board, the graphs, you see that we have a producer price, a consumer price, and then something that we call the sort of equilibrium price when there's no instrument. That is not the same thing as we're doing here. Okay, I just want to be clear. What we're doing here is we're going to have a producer price and a consumer price, and then we'll have a third price called the market price. That's basically the one that actually gets observed. And so the point of this price variable is to, maybe not in this lab, but as we continue to work with this, you'll understand that while it doesn't make any difference, or we've made the claim and we'll test it today, it doesn't make any difference if you subsidize producers or consumers. They're still going to share the benefits of that subsidy either way. But what will change is what gets shown as the transaction price in the market. And so PM, or the market price here, will always be, well, I'll take that back. It will be, if there's only a subsidy on producers or a subsidy on consumers, it'll always show up as one of those two, and it really just gives us a way of distinguishing when we're subsidizing producers versus consumers, because the market price transaction that we observe will look different. Okay, so we have our equations down here. A second change, so the three prices that include the market price is a new thing. Here we are putting both the producer tax and the consumer tax, or producer subsidy and consumer subsidy, in at the same time. So that means in the same equation system or the same spreadsheet, we are able to examine what it means to subsidize producers versus consumers. And so you see here the definitions. So when this is negative, a negative variable, it's a tax. When it's a positive variable, it's a subsidy. And then if you move down here, since we have three prices, then we're going to need, and two policy variables, we're going to need two equations that link up the prices. So one on behalf of the producer price and the producer tax variable, and then one on behalf of the consumer price and the consumer tax variable, or subsidy, right? So I just want to be clear, these are really just policy variables that say it could be a tax, it could be a subsidy, and it'll always be, if it's negative, it's a tax, if it's positive, it's a subsidy. One other final difference here, and if you read the handout, you'll get an explanation for this as well. These linking equations are not going to be the price plus some wedge or some tax amount. They're going to be the price multiplied by 1 plus a tax rate. And so it's a different kind of tax. It's called an ad valorem tax, and it basically works as a percentage. And so the logic is, if you have a 1% tax added to, or sorry, a 1% subsidy added to the producers, you find a market price, you add 0.01 to the value 1, and so the market price multiplied by 1.01 gives you the producer price. And so that just means that you're going to raise the producer prices above the market price, and you're going to raise them above it by whatever the percentage this tax variable is here, or acting as a subsidy when it's positive. So you want a 5% boost to producer prices, set that tax variable there to plus 0.05, and you'll get 5% higher producer price above the market price. So why is that important? Well, a lot of policies actually are in percentage terms. When you hear about tax rates, income tax, they're tax rates, right? They're a certain percentage above whatever the income thresholds are you owe. Sales tax is certainly one of those, where it's 7% on all the applicable transaction value. And then, of course, the implication is if prices go up for things that you want to buy that are taxable, I don't know what, gum or something that is allowed to be taxed, or then if the price goes up by $1 for something, then the tax value goes up as well, because it's a percentage of whatever that price is. Tariffs. Tariffs are often in percentage form, right? So if the market price in the world moves around for soybeans or for aluminum, then the tariff value moves with that price. Okay. Yeah, so let's think about how we might set this up in a spreadsheet. So we've been using algebraic equations in class, which mean doing some substitution, trying to eliminate things, solving for one variable, then using the solution for the first variable we find to solve for other ones. And a spreadsheet is similar. We just have to think about how we would organize it to set up our equations. Okay, and so what I've done here is sort of put some blocks together. The first being, how would you find the quantity supplied, or get the quantity supplied information into this model? And we have a intercept and a slope of the supply curve, and for now let's let the value of that be 0 and 1. And then for the quantity demanded, we have an intercept and a slope. So these are the same things we've been using in our algebraic models. We're just giving the values over here. We know that that's some upward sloping curve, or straight line in this case, for supply, downward sloping here for demand. And what we've learned as we've gone through this is that there's this gap, right? At price equals 0, there's a gap between demand and supply. There's a lot of demand for things when they're free. There's not a lot of people willing to supply things when they're free. At very low prices, you'll still have a gap. And so what really happens is we move the market price up until we clear the market, right? And so it's a way of thinking about, is there any excess supply or excess demand in this market? We tend to think of it as starting from excess demand. There's too much demand at this very low price, so let's move the price higher until we're able to clear off that excess. And so we have this market clearing condition. So basically, a market price here, PM star, is determined by the supply and demand intersection, or what we might call the market clearing condition. So the idea that we have to balance these two and produce a market situation where there's no excess supply or demand is really what we're after. And so that price is determined by that quantity relationship. We've worked through this quite a bit in class, so that this solution down here at the bottom is familiar. So you have this form of a supply equation, this form of a demand equation, it'll always solve to this. Okay, if we don't have any taxes or subsidies influencing the price, this is the price condition, the price solution. When we add taxes and subsidies, that means we need to redefine all the price variables, and so that's what's being done here. So you can refer again to the handout, which treats this the same way, but the quantity supplied equation now depends on how do producers perceive their price. What is the sort of effective price that they react to? And it could be different, and in fact it will be if there's a tax or a subsidy in the market than the price that consumers react to. Okay, what doesn't change is the market clearing, the idea that this market is not going to be something that's in equilibrium if there is excess supply or excess demand. It needs to, some price variable needs to move around and clear that off. So that gives us our three equations that are familiar to us. Now, to get into both tax equations at the same time, we need a sort of middleman price, and that is the market price. This this third entity, the market, is represented by PM. The producer response price is PP. The consumer price that they respond to is PC. And then they both are sort of compared to this this third price, whatever the market price is going to be. Okay, so again, we talked about ad valorem. This just says that the tax variable will be positive if it's a subsidy, and if you want producers to be subsidized, you make some small percentage adjustment or proportionate adjustment to the market price. So you want a 5% subsidy, it's 1 plus this value will be 0.05, and that guarantees whatever the market price is, the producer price will be 5% larger. If you want to subsidize consumers, you actually lower their price, right? So it's not the case where producers being subsidized or benefited would mean giving them a higher price, while consumers want the lower price. So again, it would be 1 minus 0.05 if you wanted to give a consumer subsidy, and that would guarantee that whatever the market price is, the consumer always reacts to or is on the hook for 95% of that price. So that links together producer and consumer prices through this common market price. And this is just a reminder that we have a condition, and this is not this is something we've just chosen. We've chosen to write these equations so that when TP and TC are positive, greater than 0, we get subsidies. That's just for this version of the model. That is not something that has to be enforced that way. In fact, you can see that if you just flip these signs to negative and positive, then you would have the tax be the positive amount. Okay, so we need to solve this problem with the tax variables included, and that is what's going on right here. I don't, the notes are here for you if you want to go through the math and work it all out. But the spreadsheet that we're going to fill in already has these done for you, so you don't have to worry about you don't even have to worry about typing in the formula, much less finding the formula. That's as I've said several times, testing your mathematics is not a learning objective of this class. We have to get some of it in there because you have to be able to demonstrate that you can work with quantitative economics values, but this kind of algebra, it's fine. So we just note down here that you end up with this market price that depends on the intercepts of our supply and demand equation in the numerator, and then every term down here has the slope of either the supply equation or the demand equation. So it's still the case that the rates of adjustment in supply and demand live in the denominator, and in the numerator it's the gap between the two, the sort of excess supply and demand, or the intercepts. What's new is that you end up with these tax variables in the denominator because of the ad valorem way that we're treating this. these tax rates directly influence the price. They're percentage tax rates. And then, of course, the effect of the tax on the price depends on if it's a producer subsidy or tax. It depends on the producer response rate or slope, and the same thing for consumers. Okay, so we're going to build a spreadsheet. So I think what I'll do is pause and let you go ahead now and open your Lab 3 spreadsheet. We'll fill that thing in, at least the first part of it, and then we'll come back to this sheet and see if we can get some confirmation of results. Okay, I have my spreadsheet open, and so we're going to fill this column in. It's called base, and so you'll see later in the lab that I'm going to encourage you to do this as the first column. Use it as sort of a base case where there's no policy, and then repeat the same exact formulas and everything, right? Copy it over so that you get the same model here, and then the only change that you would want to make then would be change the taxes and subsidies. And so we'll get to that in a bit. But for now, let's fill in our first column here. So we have some values for A and B. I think the starting values that we are going to check our results against will be 0 for A, 1 for B, and then for C I have 100, and then for D -1. Okay, so we got upward sloping supply with a slope of +1, the downward sloping demand with a slope of -1. Those are equivalent. Those are we said that we could compare supply and demand response or their sort of rate of adjustment to prices by using absolute values or nearness to 0, and so these are the same distance from 0. The market price filled in for us already, and that's good for us because it's a lot of stuff. And so the main reason I've given you that is I don't want you having any errors. I want us to do the analysis and the scenarios, and I don't want them to be wrong because you made a typo when you're putting this in. So leave that as it is, but look at it. It has the numerators here and all those denominator terms that we talked about on the slide we just looked at, and so it's all there. What you do have to introduce here are the producer price and consumer price equations, and then we need to come up with a value for Q star. Okay, so for the producer price equation, we need to get rid of that question mark, and we'll type equals, and it's just going to be, remember how we treated this, so I put an open parentheses, 1 is required, and then we're going to add that to the producer tax or subsidy rate, close the parentheses, and then put the multiplication operator there, the asterisk, and then we'll multiply it by the market price. So our equation for the producer price is 1 plus TP all together as one term multiplied by the market price. You click on that, and we don't have a tax or a subsidy down here, so the market price and the producer price are going to be the same. Consumer price, again, we need to get rid of the question mark, so let's type an equal sign, and it's going to be just like we did for the producer price, except we're now going to be subtracting. So 1 minus, and we're going to use the consumer tax variable or consumer subsidy variable down here in B18, close the parentheses, add the multiplication sign, and again multiply by PM up here, so the market price. So the market price has a determination factor for both the producer and the consumer prices, and when there's no subsidy or no policy going on the producer side or consumer side of the market, then those have to be the same. Our last piece of information here is the quantity. So some things we know. There's a single quantity in the market at equilibrium. The supply quantity and demand quantity have to be the same. So that means that we can put either the supply quantity or demand quantity in this when we build this formula. I'll just use the supply. That's what I tend to do. So we'll go with the intercept of the supply curve, B3, plus the slope of the supply curve, and B4. And now here's the one thing you have to keep in mind. Whichever quantity you're using, you need to use the correct price. And so if we're using the supply parameters or the quantity supplied equation information up here in A and B, then when we multiply the slope times the price, it has to be the producer price. If not, we'll get the wrong values. So I have B3 plus B4 times B12. Okay, that completes this top part of this that we're working on right now. So we could do a couple of checks and see if we're getting what we expect. And the slide actually has, I think, two different policies included. So the first one is a 1% tax applied to, 1% subsidy, so it's positive, applied to producers. And what do we get? A market price that falls to 49.75. The producer price is 50.25, and then the consumer price is 49.75. And then the quantity in the market, 50.25. Okay, so what's happened here is we've subsidized producers. They've been encouraged to produce more. They see a price for them that's larger than what's going on in the market. So the market price actually pushes down, right? Because the producer is in a market, when there's no policy, the price is 50. Okay, and now suddenly it's announced that you get a 1% boost to your price, right? So after the market settles out, we're going to give you 1%. So what happens? Well, that causes producers to expand production. That expansion in production has to lower the market price some, and so the settling effect is, instead of getting the full 50 cents, which would be 1% of the $50 price, they end up getting 25-cent boost, right? So the gap between the market price and the producer price is 50 cents, but they don't get the full gain of it, right? Because there's some response in the market once you start expanding production in response to that. Okay, so the market price 49.75, producer price 50.25, and then the market price tracks to the consumer price because consumers don't have any policies in play, right? This is zero. That's the only way for the market price to differ from the consumer price is for us to put a policy there. Let's check the second one, the second column on this on the slide that we were looking at had a 0 for the producer subsidy and a 1% subsidy to consumers. Okay, so what happens now? You have a tax or subsidy on consumers. That means that we're going to get a difference between the market price PM and the consumer price PC, because that equation forces those to be different. The consumer price is going to be lower, 49.75. The market price is going to be 50.25. But what is going on? Why we say it doesn't matter what you do in the market, whether you subsidize producers or consumers, is because the gap between the producer price and the consumer price is the same as we saw just before, 50.25 versus 49.75. So you give the 1% subsidy on the consumer side, producer prices go up 0.25, consumer prices fall 0.25. They get the same gains either way. What will show up as different though is this 50.25. The market price, the sort of data, if you're just someone who looks at transactions in a market, what you would see compared to the no policy case is that quantity went up some and prices went up some, right? And so we've talked about this. How would you sort of work backwards from just observing transactions and in terms of quantity and price in a market and figure this out? Well, in this case, we know that when there's no policy, the quantity and the price were lower. And so what has happened here is the subsidies to the consumer side of the market has sort of increased their buying power, right? So if you spend $50 on whatever this good is in this market, you get a 1% sort of rebate, and the consumer can build that in directly into their purchasing, which makes them expand demand just a little bit. And that expansion of demand drives up the quantity. Driving up the quantity drives up the cost to producers and allows them to expand, the cost at which producers will sell, and they get this higher price. So they capture some of the subsidy. So that's the main difference. When we add this PM variable, as long as we're only subsidizing one side of the market here, we will end up seeing that one of these will match up. And so when you subsidize consumers, you drive up the market price. When you subsidize producers, you drive it down, right? And so that's another way that we might be able to sort of untangle the effects of policies by looking at this. And of course, if you did something like, this is a mistake because I don't know what the result is going to be beforehand. Yeah, if you do something like this, then you get, that's unfortunate that those are rounding off. Add that so you can see. If you put half the subsidy on the producer side, half the subsidy on the consumer side, everything stays the same. The only difference is the market price that you see out there reported as a transaction says that prices didn't change because it's balanced between the two. Okay? And so that is what we get when we do this. Okay, I think we're done with sort of checking out the top half of this model. I just want to make a note for the scenarios that you might do later in this. So if we wanted to do, a base case versus an alternative case, then what we might do here is leave the subsidies and the taxes always at 0 in the base case, and then be comparing things in the alternative case to what happens if we go from 0 tax or 0 subsidy on producers to some positive subsidy on producers. Well, that means we could compare the columns directly. We just have to be sure that we get the model matched up correctly here. And so what you can do, or what I recommend doing, is using formulas for the supply and demand parameters. So be sure that the value for A always stays the same across both rows by setting these as formulas. The things in gray are the parameters, the intercept and slope of demand and supply. Then that way, if you make one change here and you decide that, and you decide that the slope of the supply curve is now going to be 1.5, your base case and alternative case adjust together, which is how you would want to do it, right? That's how you want to make sense of this, is comparing column B versus column C. And you can't do a comparison if things are changing between how you are modeling producer response or consumer response. Down here, the formulas are fine, so you can just copy them and paste them, right? Because you want these to look up above and do their calculations based on these values above, and then of course you could just copy these as well. These are just values. Okay, and so if you build something like this in your second row, and then we'll finish it out when we get to this other part, you'll be ready to do a comparison of no tax, no subsidy, no tax, no subsidy. And now I'm going to add a 1% subsidy to producers. Okay? And so then we could do this and just calculate the changes. We could say, what's the difference in the market price when we add a 1% subsidy to producers? So it's 50 versus 49.75. Market price falls. Producer price goes up, consumer price falls, market quantity goes up. And we could do these all as changes, right, between the alternative minus the base case. Right? So you would just have all these, and we could just call this row and in fact that may be what we what it is designed as. Okay, so you have, this stuff is going to be important to us. The other topic we had that we just got into was welfare, right? The well-being or the gains or the benefits or however you want to think of it. It's called welfare, and it's distinguished from sort of the welfare program definition, right? So we have a set of programs that we call welfare that basically look to disadvantaged groups, low-income groups, small family farms, whatever you want to think of, and those kind of get bundled together as welfare programs because the idea is to take some money and inject it, right, to sort of elevate quality of living, right? So the well-being programs are looking to sort of boost things. When we talk about sort of welfare in a market evaluation, since we're just talking about well-being in terms of surplus, the idea that if I have a high willingness to pay for something and I get to pay the lower amount in the market, then that's a well-being measure for me and that we could calculate and evaluate. Okay, so let's go back to the slides. I think we're past that. And just remind ourselves of a couple things from class. One, you can put the lowercase intercepts where C and A. This is the supply curve. This is the demand curve. And in the normal form, we have quantity on the vertical axis and price on the horizontal. And that has that direct implication, right? That if the price goes up, I want to, right? The price, I'm a supplier. The price is exogenous to me. I see the price move. I want to supply more, right? I see the price move up here. I want to supply more. It has the same implication for consumers. From the market context, the quantity and price are endogenous. We move over here to the inverse form because, one, the mathematics of a market equilibrium say it doesn't matter if you present it this way or this way. But the nice thing about this version is if you start tracking down the demand curve and you say there's a person or there's a purchaser at this point of the demand curve, they are willing to pay this much, right, at this quantity. Okay, and so that we call that their willingness to pay, and then we move all the way down here and say the equilibrium price will be where these two intersect. And so it must be the case that the person with a willingness to pay up here gains from being in this market equal to the amount of the gap between what they're willing to pay and what they're required to pay. And then of course we did the same thing from the supply side. And so it's just a matter of, obviously, you could do willingness to pay in this direction, right? This must be the willingness to pay for this consumer, the willingness to pay for this consumer. But it's just much more natural to measure these things in terms of the distance up here, because in this one it's falling, and in this one it's moving in that direction, right? So that's our big switch when we go to calculating these sort of welfare or surplus measures, and it requires us to go from lowercase c to uppercase C, lowercase a to uppercase A, and we have the formulas for those. So in lecture, we say we're going to use the inverse form to get consumer and producer surplus, and we had this formula for capital A. Just take the negative of lowercase a and divide it by B. And then for capital C, we have the negative of lowercase c over D. We need both of those for calculating the height of our consumer surplus and producer surplus triangles. That should say PS. The other thing we have to deal with, we have two different prices now. We have a price that's for the producer and a price for the consumer. And you shouldn't be surprised to think that we're going to use the producer's price when we calculate producer surplus. We're going to use the consumer price when we calculate consumer surplus. Okay, so the welfare measures under a tax and a subsidy, we can have producer surplus, consumer surplus, and total surplus. And we have a couple more that we haven't covered yet in class, but it's time that we introduce those. There's a third stakeholder in a market. So you have the producer side of the market, the consumer side of the market, and then if you're going to have policies, then you could say the government, but really the taxpayer is the stakeholder. Okay, so the idea is if you're adding taxes in a market, it's to you're taxing producers and consumers in that market who are also part of the taxpayers, right? And so taxpayers are trying to pull revenue out of a market to buy things that there aren't markets for, right? We don't have markets for military. We don't have markets really for roads, right? Sort of these public services that the government acquires the land, they lay the blacktop out, but they don't do it for free. They do it by collecting revenues, and so the idea is you get to consume those. You just don't participate in a market to do it. It's done sort of through the taxpayer account. So when we're in a market and the producers and consumers are subsidized, it's because there's some sort of public interest in boosting output in that market, typically, or boosting the returns to producers in that market, and we incur a cost as taxpayers. So if we want a larger food supply or a larger agricultural supply to guarantee a larger food supply, those subsidies get charged to taxpayers, right? So you don't bid on this. It's not a market thing. It's done on behalf of the taxpayers as a government or a public project. So if you want to do this, then we need to calculate for a subsidy, what is the taxpayer cost of subsidizing this market? And in the case where you tax a market, well, you're going to get some negative value, and so the taxpayer cost is actually a gain or a revenue item for the taxpayer account. In all of these, we just take the producer price minus the consumer price. That will always give you the taxpayer gap, multiply it by the quantity, and you have the taxpayer account from whatever policies we're doing in a market. Then the final measure is the deadweight loss. Okay, so it is the case that when you collect revenue by taxing in a market, or you add subsidies into a market to boost output, you lose some of that willingness to pay, willingness to sell efficiency. Some of the welfare, the surplus measure, gets eaten up, okay? And so you have efficiency loss, and we call it the deadweight loss. It's the fact that once you interfere in a market, you start incurring losses that you can't find anywhere, right? So the taxpayer amount, right, what you collect in taxes out of this market isn't necessarily lost, right? So it's taken from producers and consumers, but it's also given back in terms of roads, right? And so most transactions require transportation. Most transactions require, sort of stable information systems, right? Government collecting consumer price data, those kind of things. And so, it's in a sort of pure welfare term, the taxpayer dollars collected aren't lost in the system, right? They are still there and available for benefits to be purchased back for producers. Subsidies spent into this system are potentially being spent on behalf of the public to try to generate gains that the public needs. The deadweight loss is completely different. It is the fact that you just lose the money. It just disappears because it's inefficient to tax markets. Okay, and so what we want to do then is identify the lost surplus, or the lost amount of sort of value in a market compared to that free market situation. So what we'll do is first we'll calculate the total surplus, the PS plus CS, when there's no tax or subsidy in place, okay? And if you wanted to do that, you could calculate it using this formula, TS prime. It's just going to be another triangle. It's a half times the quantity times C, that intercept of the inverse demand curve, minus A, the intercept of the inverse supply curve. you could plug it in here, and you would see that TS prime is by substituting the supply equation. However you want to do it, right? We have these things in the spreadsheet, and so when you look at the spreadsheet, you'll see this is how they're calculated. So first, we calculate the total surplus under no taxes, no subsidies. Second, calculate the taxpayer cost. It'll be a receipt for taxes. It'll be a cost for subsidies. And then third, we compare the total surplus when we have taxes and subsidies to the free market total surplus plus the taxpayer cost. Okay, so what we're looking for is, if you take the market that is now subsidized and take the total valuation, is it the same as if you had just taken the total surplus from the original case and added the taxpayer cost of the subsidies? And what you should find, if there is dead weight loss, is that the total surplus of the subsidized market is actually less than what it would happen if you just added together the total surplus plus the taxpayer cost. Okay, so we need to fill in our spreadsheet and finish this up, and let me switch back over to that. Okay, I didn't ask much of you here, it looks like. I just want you to put formulas in for A, capital A, and C, and so we can do that now. Let's go with equals. Remember, there's a negative sign that we have to include, and then just grab the parameter A and divide by the parameter B. Okay, so it's negative B3 divided by B4. Hit enter, and you see 0 stays at 0. Now we need the inverse demand, so we'll go with equals. We need a negative, so it's negative B7 divided by B8, and you'll see it's 100. So this is that actual sort of rare case where the A and C doesn't actually change, and you can see that that is dependent on either A being a value of 0, because when you invert that it stays at 0, and then in this case D has to be a value of -1 to keep the value of little c and large c the same. Okay, if we scroll down through here, you'll see everything else filled in for you. We have an inverse supply and inverse demand that we just added. The free market total surplus is $2,500. Producer surplus and consumer surplus are $1,250 each. We expect that because they have the same values or the same distance from 0 for the supply slope and the demand slope. The total surplus calculated a second way. So this first formula here calculates the free market total surplus without regard to any policies, right? So those are not included here. The second way just adds up producer surplus plus and consumer surplus to get the total, and those do include any policies that you might include in column 1. The taxpayer cost, we don't have a subsidy or a tax right now, so there's no accounting for the taxpayer, and if you're not including any policies, you don't get any dead weight loss. But if you move back up here and you put 0.01 in, the producer subsidy that we've been, that 1% producer subsidy that we've been testing, you plug that in, and you see the free market total surplus doesn't change. The actual subsidized total surplus does change. It goes up by 24.94, and you see that the taxpayer cost of that was 25. Okay, and so this says that take the free market, add to it the taxpayer cost. 2,500 plus 25 is 2,525. Do you get that full amount as the total surplus in the subsidized market? You do not. You lost 0.06, right? So there's this dead weight loss in this market because you do not get the full $25 the taxpayers spent as benefits, right? So the ideal policy, right, in terms of efficiency, right, you debate whether it's good policy or bad policy somewhere else, But in terms of welfare analysis or efficiency analysis, you say the ideal policy would take this $25 that we pulled away from taxpayers to inject into this market, and then it all ends up as either producer surplus or consumer surplus. We don't have any sort of leakage or bleeding out of money, and in fact you do in this market. And of course the deadweight loss here will always depend on things like the slope of supply and demand and the size of the subsidy. Right? So if you change the subsidy, you see that you start to incur more deadweight loss, of course more taxpayer cost, right? So those are growing together. But in our lab we're going to try to keep this this column always as the sort of free market case, the base case. And so what we'll do then is we'll just copy, you can go ahead and do this now, copy all of these cells over, and you see the results show up again that we just did. So the 1% subsidy case tracks through. And so the other thing that you could do here is we calculated changes in the market price, producer price, consumer price, and the market quantity. Well, down here you could calculate the changes in producer surplus from the original to the from how much does producer surplus go up when we subsidize the market, how much does consumer surplus go up, how much does total surplus go up, and then how much do taxpayers costs change. So taxpayer costs go up by 25, total surplus only goes up by 24.94. That is your inefficiency, and that would give us this deadweight loss down here that you were looking for. Okay, I think that finishes building in our spreadsheet. I think I have probably one more slide that we can talk about. If I can get it to open here. Okay, we just finished that one. Oh yeah, so I always get asked, why do we calculate deadweight loss this way? Well, one, it's the definition of deadweight loss. It's the efficiency loss here, right? So we are not, when we're doing these quantitative policy evaluations, these are for the economic transfers, right? We are trying to track down the incidence of the policy in terms of how much money for subsidies, how much money goes to each side of the market, and for taxes, how much sort of burden flows to each side of the market. So those are the sort of two stakeholders directly in the market, and then we come to the third stakeholder, the taxpayer. So if you are investing a taxpayer fund, right, so think of it that way, into a market, right, you're saying one of the objectives of policy is to boost output in this market. A way to do that is subsidizing. So that's an investment of taxpayer funds for some public objective of raising output. And so to do that, on behalf of the taxpayer, we want to think about what is the best way of doing that. And so deadweight loss and measuring sort of this this loss in transfer, this sort of bleeding of money as you inject it into a market is one of the ways that we sort of do evaluation on behalf of sort of the public budget. Same thing when we collect taxpayer funds. Are we collecting taxpayer funds from a market that is sort of an efficient place to collect money for public projects, or are we not? Okay, and so we just end up sort of with this benchmark of deadweight loss being the free market surplus that already exists when you don't have policy, and then plus the direct transfer of treasury dollars. So anything short of that, anything short of this in a subsidy situation is money that's being bled out of the market. You had this market with all this surplus in it. You decide to use it to either collect money or to subsidize it further because it's an efficient or an important market. Whatever that surplus gets bled out, gets lost, shows up as deadweight loss, right? So it is what it is, right? It's called deadweight because it is completely dependent on the fact that you are interfering from what we would call first best or maximum efficiency situation. So the best case in markets is producers and consumers interact and make decisions based on common willingness to pay and willingness to accept. When you put a gap in there, a subsidy gap or a tax gap, they are now no longer to make transactions all the way till all the willingness to pay and willingness to accept is there. And so you end up with that gap, or sometimes it's called the dead weight loss triangle. But either way, it is there, and it's loss that we keep track of. Okay, I think that closes out the lab. I think if you look at the handout, you'll see that I'm asking for you to complete 6 scenarios. Sorry, I think the sound cut off there. I think you're asked to do 6 scenarios in the spreadsheet. You could do those just as a series of columns here, or you could just each time record your values. So use the alternate side here, do what the spreadsheet instructs you to do, record the changes, and then move on and change as needed for those 6 scenarios. But either way, fill this thing in, work on it. I think it's due next Wednesday, and we'll talk about it in class when you hand it in.